Okay, hello and welcome back. In this video, we're covering section 7.6 on solving quadratic equations by factoring. So we've been practicing a lot of factoring skills, and it's been building up until this point where we'll be able to solve equations using factoring as a method. So just like before when we were solving equations that were linear, something like 3x plus 2 equals 8, something like that, and we were asked to solve. Well, this involved going through some operations until we just get x equal to some value. Like we found out what values of x make this equation true. And for a linear equation, we just had to move everything to the other side. Like I would subtract the 2 over and then divide by 3 and say x equals 2. This is the value if I plug this in. Yeah, 3 times 2 is 6 plus 2 is 8. It creates a true statement. So we'll be able to now solve a quadratic equation. An example would be something like 3x squared plus 2x plus 9, just making one up, or x squared plus 4x plus 4 equals 0. And I'm setting these equal to 0, and that makes them an equation. So what we're going to do is use factoring in order to solve this. We'll be able to find out what values of x will make these statements true. What will be the solutions to these equations. So in order to do this, first we need to introduce something called the zero product rule. And then we'll introduce the method of solving a quadratic equation by factoring. So first, let's look at that rule, the zero product rule. This says in general, if a times b equals 0, then either a equals 0 or b equals 0. Or they could potentially both be equal to 0. So let's think about what this means. If a times b is equal to 0, well, two things are multiplied, and we know that if you multiply 0 by anything, it will make it 0. Like 0 times 10,000 will be 0. So that means a could be 0. We could have 0 times whatever b is, and that will be equal to 0. So we could say a is equal to 0. Or another option is that b is equal to 0. We could say a times 0, whatever a is, will be equal to 0. So therefore b is equal to 0. So we get these two options, a is equal to 0 or b is equal to 0. This will produce multiple solutions whenever we are solving a quadratic equation by factoring. Because if you recall with factoring, we end up with things like this in our example. Two things that are multiplied. And we'll see that we'll end up with these being equal to 0. So this will be the property that we'll use ultimately to solve to get some kind of solution. Let's see a couple examples just to make some more concrete sense. So in example A, we have p, that's our variable, times p plus 4 is equal to 0. These are two things multiplied equal to 0. That's like our a and our b. So p times p plus 4 is equal to 0. We're able to split off into two directions. Either p is equal to 0, that's our first thing on the left, and that gives us our first solution. It's already solved for p. Or we would say this other piece, which is p plus 4, is equal to 0. And I would just need to solve for p, so we get a little linear equation. So I would just subtract the 4 over, and p would be equal to negative 4. So notice we get two solutions here. And we can plug these back in and check to see if it makes sense. Does it make a true statement? Let's take 0 for our first case. This will be us checking our answer. So when p equals 0, this would be 0 times 0 plus 4 Well, that's 0 times 4. 0 times 4 is equal to 0, so it equals the right-hand side. So that's true. So how about if p equals negative 4? This would be negative 4 times negative 4 plus 4. That will be negative 4 times 0, which is equal to 0. So both of these values, negative 4 or 0, produce a true statement. We'll call those both solutions to this equation. So let's look at part B. We have a similar situation, 3x plus 1 times x minus 7. And this is equal to 0. So we have two things multiplied. First thing times the second thing. Those are our two factors. This was the result from factoring some expression. So we can set the first factor equal to 0. 3x plus 1 equals 0. And solve for x. So I'll subtract 1 over. So 3x will equal negative 1, and then divide by 3. X equals negative 1/3. Or we have our second option, our second factor, x minus 7. That also could be equal to 0. Add the 7 over, and we get the second solution. X equals positive 7. So these would be our two solutions. We'll start a little bit farther back on the process and factor until we get something like this, but this will be how we'll actually get our solutions. So this is how we'll actually solve in the end. So with this in mind, the zero product rule, let's look at solving a quadratic by factoring. So again, a quadratic equation in the general form looks something like ax squared plus bx plus c equal to 0. This is a quadratic equation. You can see we have a trinomial with the highest degree of 2. We have the second power. That's what makes up a quadratic, and it's an equation because it's set equal to something. In this case, it's set equal to 0. So that's our text definition of a quadratic equation. It means it can be written in this form, ax squared plus bx plus c equals 0. It might be more scrambled around. We might have to like rearrange it first, but we can ultimately put it into this form. And they say where a, b, and c are real numbers and a is not equal to 0. So if we want to solve a quadratic equation, it's kind of a three-step process. So I'll write it out here. So the first step is to set everything equal to 0. And we'll see an example in a second. So that's a little bit different from solving a linear equation where we're trying to get everything except for x to the other side. Now here we're getting everything on one side equal to 0. That should give us something that we can factor. So that's the second step. So we've gone over a bunch of factoring techniques and situations in a lot of our previous sections. So we'll be able to use all of those skills to factor. We'll get two or more things multiplied equal to 0. At that point, we can apply the zero product rule and solve. So let's see an example. So let's say we have an equation that looks like x squared plus 6 equals negative 5x. So in general, you know you're in a quadratic situation if you see a squared variable with maybe some number in front, then that same variable to the first power with some other number in front, and then some just general constant term, something that doesn't have and x, or whatever your variable is. So we can see that here we have x squared, or x to the first power is on the other side with the negative 5, and then we have the 6 without an x. So let's do step 1. Let's set it all equal to 0 and get it on the left side into this standard form. So I'll add the 5x over, and I'll place it in between the x squared and the 6 just to get everything set up. So it would be x squared plus 5x plus 6 is equal to 0. So now let's factor. So this was step 1. So step 2, let's factor this. In this case, our a term is 1. Let's look at factors of 6 that add up to 5. That should be 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. So on the left side, that should factor into x plus 2 times x plus 3. So that's where we've stopped before, but here we're in an equation. This is equal to 0. And then now we have two things multiplied, these two factors multiplied equal to 0. So step 3 is to apply the zero product rule, meaning we can say the first factor, x plus 2, is equal to 0, or the second factor, x plus 3, is equal to 0. Notice we have two little linear equations that we can solve. So on the first one, let's subtract the 2 over, x will equal negative 2. Or on the second one, subtract the 3 over, x equals negative 3. And technically our last step, we could plug these in and check to see if this makes sense. Like for negative 2, if I plug it into the original equation, we can even do the rearranged version from step 1. Negative 2 squared would be positive 4. We'll add it with that 6, so we can imagine we have 10. And then here we'll have 5 times negative 2, which gives us a negative 10. So 10 minus 10 will equal 0. That will be one solution. Or when x equals negative 3 squared would give us positive 9. 9 plus 6 is 15. And then 5 times that negative 3 would give us a negative 15. So if we plug those in, we would get true statements both times. So technically the last step would be to check our answer. But this will be the general pattern that we'll go through, and this is how we can solve using these factoring methods. So the text gives their lists, similar lists that we just looked at. So they say first, write it in the form ax squared plus bx plus c equals 0. That's what we're calling the standard form. So that all terms are on one side of the equal sign and 0 is on the other side. Then factor the expression. Then set each factor equal to 0 and solve for the variable. That's applying the zero product rule. Then they add step 4, which is checking your answers. So let's start going through some examples, and we'll follow this procedure and solve as many as we can. So let's start with example 2. So we have y squared minus 6y minus 16 is equal to 0. So it's already set equal to 0, so we've already achieved step 1. Set equal to 0. So now let's factor. Our a term is 1, so I would just look at that negative 16 and try to find two things that multiply to equal negative 16, but when I add them together, I get negative 6. So you can guess and check, play around with some values. I know 16 is 8 times 2, and I want it to be negative, so one of those should be negative. So if I do positive 2 and negative 8, 2 times negative 8 is negative 16, and then 2 minus 8 will give us negative 6. So that means this will factor into y plus 2 times y minus 8, and this is still equal to 0. So this is step 2, just factoring the left side. Okay, now let's apply the zero product property and solve. So our first factor is y plus 2. We can say y plus 2 is equal to 0, or the second factor, y minus 8, is equal to 0. So solving each of these, on the left side, if we subtract the 2 over, we get that y equals negative 2. And then on the right side, add the 8, y will equal positive 8. So we get 2 solutions. And this was step 3, applying the zero product rule and solve. All right, let's look at example 3. It has a bunch of more problems we can try. And we'll go through this process. I won't write out each of these steps, but that's the general flow that we're going to follow. And let's keep in mind other factoring techniques as well. We've seen a couple simple cases, but remember there are a whole bunch of different variations that we might run into. So we'll see a few of them here. So let's start at part A. We're given 2 times t squared plus 7t equals 15. So step 1, let's get everything over to the left side equal to 0. So let's subtract the 15 over. I'll get 2t squared plus 7t minus 15 equals 0. So now we want to factor. This time our a value is greater than 1. We have 2t squared. So this is where I will use the AC method. I'm going to multiply 2 and my last term, negative 15. That gives me negative 30. And then it's this number that I think of two factors that multiply to negative 30 that add up to our middle term, which is positive 7. Well, I know 10 times 3 is 30. If I want it to be negative, one of them should be negative. So I could imagine positive 10 and negative 3. That'll give me negative 30 if I multiply them, and then 10 minus 3 is 7. So in this method, the next step is to rewrite the middle term. So I'll write this as 2t squared plus 10t using these two numbers. So 10t minus 3t minus 15 equal to 0. And then now let's factor by grouping. So put it into two groups. We'll have 2t squared plus 10t plus our second group, negative 3t minus 15, still equal to 0. Now let's factor out as much as we can from these two sets of parentheses. So the first one, we can take a 2 out and also a t, and we would have t plus 5 left over. In the second set, they both have negative 3 in common, so I can take a negative 3 out. Then I would have t, and a negative 15 divided by negative 3 gives me positive 5. So I see my common factor, t plus 5. So that gets pulled out in front. And then the second factor will be the two coefficients, 2t and minus 3. So it took a little bit of extra work to get to this part where we have our two factors multiplied equal to 0. So that's via the AC method. If you need to return back to that previous section, you may be worth reviewing. Let me see which section that was. Possibly, yeah, 7.3. So if you want to go back to that video, you can check out that method. So let's continue here though. We have our two factors. Let's set them equal to 0. t plus 5 will be equal to 0, or our second factor, 2t minus 3, also equal to 0. On the left, if we subtract the 5, we get one solution, t equals negative 5. And then on the right, we would need to add the 3 over. 2t will equal positive 3, and then divide by 2. So t will equal 3 over 2, 3 halves. And those will be our two solutions. So the general process was the same. We still set everything equal to 0, then factored. So all of this was our step 2. It took a few extra steps due to having to use a slightly more complicated method. And then we apply the zero product rule and solve. So still following the same general flow, just depending on what we're starting with, we might have to use a slightly different factoring method. So let's look at part B. Another example, we're given 9v squared is equal to negative 54v. So step 1, let's get it equal to 0 on the left side. I'll add the 54v over. And this is equal to 0. Now it doesn't quite look like a regular quadratic, ax squared plus bx plus c. We basically just have the first two terms. So always try to factor out some greatest common factor. It looks like they both have v in common. And I know 9 times 6 is 54. So they both have 9 in common as well. So that means we can take out 9 and v. From our first term, we'll just have v left over. And then 9 goes into 54 6 times. And we took the v out. So we'll just have v plus 6. So a little greatest common factoring. And you can always multiply this back through just to check, did I factor correctly? That would give us 9v squared plus 54v. So we factored. Now we have two things multiplied, 9v and v plus 6. So we can apply the zero product property here. We can say on the left side, even though it's not in parentheses, it's still another factor. We can say 9v equals 0, or our second factor, v plus 6 is equal to 0. So on the left side, divide by 9, we get that v equals 0. And then for our second solution, subtract the 6 over, v will equal negative 6. In our text and in the homework, they like to give the solutions as a solution set. So you might see curly bracket notation with these two numbers inside, 0 and negative 6. So it's a set, it's like a little container that has our two solutions inside. All right, let's look at part C. We're given h squared, and this is equal to negative 5 times 2h plus 5. So it's all kind of scrambled up. Let's try to get rid of the parentheses and get everything over to the left side. So let's first distribute the negative 5. So that will be negative 10h minus 25. Then let's move everything over to the left. So I'll add the 10h over. So h squared plus 10h. And let's also add the 25 over. And this is equal to 0. Now let's factor. Let's think of factors of 25 that add up to positive 10. Well, that should be 5 and 5. 5 times 5 is 25. 5 plus 5 is 10. So we'll actually get repeated factors here. So we can write this as h plus 5 times h plus 5. So that means we would do this twice, but we'll get the same answer both times. We would say h plus 5 equals 0. So subtract the 5 over. That means h is equal to negative 5. So you won't always get two solutions. And there's some visual reasoning behind that if we're thinking of the graphs of these, which I'll save for maybe a college algebra course. We look a bit more deeply into what these equations look like in a graph and what they can represent, and what it means to be a solution and what that looks like on the graph. But for now, just know that you may not always get two solutions. It'll depend on our problem. In this case, we had a repeated factor, so technically we get the same solution twice. All right, I think there was one more part here, part D. D gives us w minus 4 times w minus 5 is equal to 2. So it's tempting to apply the zero product rule here because we see that things have been factored already on the left side, but it's equal to 2. So that rule only applies if it's equal to 0. So what we actually have to do here is multiply everything out and then get everything over to the left side equal to 0 and then refactor. So let's start by multiplying the left side. If we FOIL this, the first two terms would give us w squared. Then w times negative 5 will give us minus 5w. Then the inner terms will give us minus 4w. And then the last, negative 4 times negative 5 will be positive 20. And this is equal to 2. So let's combine our like terms on the left side and subtract the 2 over. So that should give us w squared minus 9w minus 5 minus 4. And then subtracting the 2 over, this will be plus 18 equal to 0. So now let's factor this. We're looking at factors of 18 that add up to negative 9. So now 18 is 9 times 2, but that would give us like 7 or 11. 18 is also 6 times 3, but that would give me positive 9. So if I want a negative 9 but to multiply to equal positive 18, we can make them both negative. We can say negative 6 and negative 3. When we multiply, we'll get positive 18, and then when we add them, we'll get negative 9. So this will factor into w minus 6 times w minus 3 equal to 0. Now let's apply the zero product rule. We can say w minus 6 is equal to 0, or w minus 3 is equal to 0. So adding the 6 over, we get w equals 6, and adding the 3, w equals 3. Or as a solution set, we can say the set containing 6 and 3. Maybe I'd put the 3 first, but that'll be all right. So we can also use this method to solve higher degree equations. So let's see what they mean. In our first example, part A, we are given 4x minus 1 times x squared minus 8x minus 20 equals 0. If we were to multiply this all out, we would get some third degree expression. But we can still apply the zero product rule here. We can, because we have two things multiplied. This first 4x minus 1 times this whole thing. So let's just set them both equal to 0 and solve. The first one would be 4x minus 1 equals 0. So let's go ahead and solve this one. I would add the 1 over, so 4x equals 1, and then divide by 4. I get one solution, x equals 1/4. So easy enough. Let's look at the second factor. We'd set that equal to 0, x squared minus 8x minus 20 equals 0. So now our a term is 1, so we'll just look at negative 20. Do things that multiply to negative 20 but add up to negative 8. Let's see. Well, I know 20 is 5 times 4, but that would give us 9. 2 and 10. If we make the 2 positive and the 10 negative, 2 minus 10 is negative 8, and then 2 times negative 10 will give us the negative 20. So this will give us x plus 2 times x minus 10 equals 0. Now let's again apply the zero product rule. You can say x plus 2 equals 0, so x would equal negative 2. Or x minus 10 equals 0, so x equals positive 10. So notice here we actually get 3 solutions. Because inside one of these factors was a whole quadratic equation itself, which we can solve, and that gave us 2 solutions. So with this in mind, let's look at part B, and I'll recopy it down here. So we're given 12n cubed minus 108n equals 0. So what should we do? It looks like they both have n in common, so we can factor that out. And then it turns out that 108 is divisible by 12. 12 times 9 is 108. So they're both divisible by 12. So let's factor that out first. It's always good to factor out a greatest common factor if we can. So we'll take 12 and an n. So inside the parentheses, that would leave n squared. And then 12 goes into 108 9 times, so this will leave minus 9, and we took the n out. So the question now is, can we factor this further from here? Well, looking inside the parentheses, we should notice a difference of squares pattern. We have 12n, n squared, well that's n squared, and then 9 is 3 squared. So if you recall difference of squares, if we have a squared minus b squared, this can factor into a plus b times a minus b. So let's use that pattern here. We'll still have the 12n on the outside, and we had n squared minus 3 squared. So that should become n plus 3 times n minus 3. And this is all still equal to 0. So now we have 1, 2, 3, 3 factors. So they all could be set equal to 0. So the zero product rule works with more than just 2 factors multiplied. So we can say 12n equals 0. Well, dividing by 12, we get that n equals 0 as our first solution. Second one, n plus 3 equals 0. So subtract 3 over, we get n equals negative 3. And then the third one, n minus 3 equals 0. Add the 3 over, we get that n equals positive 3. All 3 of these are solutions to our original expression. So we can use a similar method of setting things equal to 0, factoring as much as possible, and then applying the zero product rule to things beyond just a second degree quadratic. All right, that completes this section. So we learned about the zero product rule. That's how we solve things of the form just a times b equals 0 when it's already factored out. Then we solve quadratic equations by factoring, and then some higher degree equations also by factoring. So this will be a pretty key skill going into higher level classes like college algebra, even everything above that. You'll typically end up having some kind of situation where you need to solve an equation by factoring. So it's a really pivotal skill, and the more comfortable you can get with it um, as early as possible, the better, and that will help you out a lot in a lot of classes moving forward. All right, that'll be it for this video, and I'll see you next time.